at that crane over there. That looks neat. Let's go take a look at that thing. Look at that. Steam crane. Hey Bob, bring the camera over here. Let's get some shots on this steam crane over here. This thing looks pretty neat. Cyrus here. Hey man, look at this sawmill. It's a good sized blade on that mill. Wow, look at this, tandem drive. Look at this, 2 steam engines running a common shaft to run the mill. Hey, that's all right, I like that.
big dude.
Good size then.
Standard 8. Probably for this. Here.
Hi, my name is Tom Spencer, and we're here at the Rough N Tumble Showgrounds in Kinzers, Pennsylvania. With me is Nate Lillybridge, one of the members of the large engine committee here at Kinzers. And Nate, can you tell us something about the quantity of engines you have here on display?
Well, we've probably got about 25 or 30 engines in this building and another 70 engines or so around different other buildings in the showground.
I see. And how about the age of some of these engines?
Well, the oldest engine we have here is the one directly behind you, Tom. That engine was built about 67, excuse me. Well, that's an Otto engine. That's a real unique piece. That's a slide valve engine. Nice item.
I see. Now, as far as some of these engines goes, they're single-cylinder and twin-cylinder engines. Basically, not too many multi-cylinder engines.
No, I would say here at Rough N Tumble we have one of the finest collections of engines on the East Coast, probably in the United States for that matter. But we have horizontal twin-cylinder engines, and we have vertical engines. We have twin vertical engines, and also the standard horizontal engine, you know, with 2 flywheels.
Correct.
We have an excellent cross-section of engines here.
I wonder if you could take us around and show us some of them.
Sure.
We could take a look at that Klein engine
Sure.
and, you know,
no problem
check that
at all.
out. Right.
Hi, Al.
How you doing?
This is Tom. This is Al Stickney.
Hello, Al. How we doing?
Another one of the members of the big engine committee here at Rough N Tumble has got some nice pieces around the places too also.
Great. Maybe Al can take a walk with us and show us around, show us some of the other engines here on the showgrounds.
Good. Whenever you're ready, let me know.
Very good. Thank you, Al. What engines do you have in this particular building here?
I would judge from 25 to 30.
And when do you run these engines?
Basically 3 times a year. A couple days in the spring opening, and for our 4-day meet here now, and the 2 days in the fall.
I see. And when is the best time to see these displays running?
This is the best time this week because a lot of the engines are owned by individuals, and they come from all over the country to run them.
I see.
And so it's the biggest get-together would be these 4 days.
All right. And most of these engines within the 4 days will be running, I assume.
Yes, as the members show up, they'll run their individual-owned engines.
Who owns the individuals? Individuals own most of these?
There are some of them belong to the organization, and the majority to individuals.
I see. Well, let's go over and talk to some of the individual owners of these engines.
Okay, fine. This is Mike Foucault. Mike's been a collector here since about 1970, and he's going to tell us something about his Simplex engine. Mike?
What I have here is a 15 horsepower Simplex engine built in Oil City about 1902. It has a 10 by 15 bore and stroke. It has a hit-and-miss governor, and it has a magneto ignition, which was put on in the 30s. It runs at about 165 RPM. In this portion of the engine, this is the intake valve, this is the exhaust valve, the valve chest into the combustion chamber. You have your push rod going back to the timing gear, and the way it works, when it goes on the governor, the latch holds the exhaust valve open. The speed is controlled by the weight of the tension of the spring on the governor weights. This is the magneto ignition, which was put on in the 1930s. Originally it was hot tube ignition. Flywheels are 5 feet diameter, 10 by 15 bore and stroke. The engine weighs approximately 5,300 pounds. On top is a temperature gauge. This is your cooling water discharge from your water jacket. Back here is your cylinder lubricator. This is ported exhaust. It has an auxiliary exhaust port. Most of your exhaust goes out this when the engine fires. That's where you can hear the loud crack. It's basically a volume for the engine to draw upon. This oil acts as a seal. You have pipes inside, and it fills with gas. After the engine takes a charge, the gas will fill this up and shut the valve off here and wait for the next cycle of operation. All this is to have a volume to draw from. That way you're not drawing all through your regulator.
Thanks, Mike. How about showing them your Bovard C-Fang air compressor?
Sure, we'll go right to the back of the building. What we have here is a Bovard C-Fang combination engine and air compressor. One piston does both functions. This side of the engine is the combustion chamber. This is your intake valve. This is your exhaust valve. The rear of the cylinder is sealed by means of a packing gland. You have two feather valves. This is the discharge valve. On the bottom is the air intake valve. This also has a pendulum governor, which misses the exhaust valve when the engine gets going at a certain predetermined speed. This engine also has a crosshead in it, and it's self-oiling. It's quite a well-built engine. It's only a 5.5 by 7 bore and stroke. That's the crosshead. Right here, here's your timing gears. This is your magneto. This engine was built around 1920. It supplied starting air for a much bigger unit similar to this, which had a 16 by 20 bore and stroke. Right now we're using it for our starting air system here at Rough N Tumble for starting the big engines. It will pump 175 pounds per square inch, and then the pop valve lifts on the air system. Start this up for you, show you how it works. First thing we have to do is make sure we have our flow of cooling water to the engine. Next we have to turn on gas. We're using propane as a fuel. Originally it was natural gas. Set all the lubricators, which are several of. Set our magneto to the start position. Open our discharge valve to the system.
Yeah, we will. We'll get to it.
Set our gas cock to the correct fuel mixture. All this little device is to decompress so I can start it. Advance the timing, give it a little bit more gas. And then on the bottom we have the unloader valve, which will make the compressor compress air. Set our mixture, and then we sit and wait until we get the full amount of air in the tank. And that's all there is to it.
Thanks, Mike. We're going over and talk to Klein.
Appreciate it. Okay.
He'll interview you, or you tell me anything about the AG1 as you're going. Probably just starting and tell them about how to start it, or what you're doing to start it. Cuss a little bit when it don't start. This is Clyde Burkholder, and he's getting ready to start his engine. He'll show you how to do it.
I'm going to pour gasoline in the primer. I'm going to use a regular match to store it. That's my store. I'm going to run it back into compression and then hit it, hoping it starts. Fairbanks. And we ran a feed mill in Morrisville, Pennsylvania. We built here about 20 years ago, and haven't hardly did a thing to it. Just worked ever since. I'd say the weight of it's about 7 tons. I bring it back against compression, and you just put a regular match in there. And when I hit it with my fist, it smashes the match and sets off a spark. That sets off the gas, and that sets her off running. And the size is a 40 horse. The bore is about 11 and 7/8, and I don't really know the stroke. About a foot stroke. This ran a line shaft in a feed mill, and anything it ran a generator, a water pump, and a line shaft.
What condition was in? How long ago did you get a fired
About 20
engine?
years ago, and I haven't did a thing to it. I brought it here and started running it, and that was it. Didn't do nothing. It's a very good engine.
This is Mike Murphy. He's running Nate Lillybridge's engine here today, and he'll explain it to you.
Okay, this is a 50 horsepower Hornsby-Akroyd oil engine. It was built right at the turn of the century, and this one particular engine ran a waterworks in Hyannis, Massachusetts, and that's where it was pulled out of before it was brought down here. The way this engine operates, it's really a predecessor to the modern diesel. The little pump down here operates off the intake valve lever, and it fires a shot of oil into this part of the engine. So it is like a modern diesel in the fact that it has a solid injection system. The way this engine operates is the cylinder stops here at the head, and this is the unit right here is called a vaporizer. And to start this engine, you have to turn this torch on back here and blow hot air into, or flame into this opening here and keep the front of this vaporizer unit up. The compression pressure on this engine is only about 60 psi, so it doesn't start cold like a modern diesel engine. When you get the vaporizer warm, you give the injector a couple pumps and you shoot some oil into that vaporizer. That oil then heats up and evaporates. When you roll the thing through, as the piston comes through on compression, it pushes air through a small orifice in the front of this head, between the head and the vaporizer, and shoots oxygen in where that vaporized oil is. That causes combustion, and the combustion pressure then blows a lot of unburnt fuel out into the cylinder where there's a lot of fresh air, and you get combustion, which then pushes the engine through its cycle. This is the governor here, and as you can see, this engine runs real smooth. It's really a well-governed engine. You can speed it up and slow it down by changing the position of this small weight. If we move it in there, you'll see the engine start to speed up. It's very massive flywheels and counterweights, so it'll take a few seconds before you see the speed starting to come up. Most of the engines like this that were sold were used in the oil pipeline pumping service. They drove large triplex oil pumps that forced oil through pipelines. This engine is of English origin. This particular unit was built by the De Laverne Machine Company in New York, who built lots of refrigerating equipment. They also got the patent, or got the American rights to this machine, and they sold them throughout the country, and most of them, like I said, went into oil field service. I'm going to slow it back down. This engine is a 50 horsepower Miller improved gas engine. This particular engine drove a flour mill down south of Pittsburgh, Pennsylvania, and in the Pittsburgh area. This particular engine runs on the 4-stroke cycle. And you can see up here, this is the exhaust valve. It's run by this part of the cam here. The exhaust valve, actually, the seat sits down here and allows the exhaust gases to come out, but it's operated by this mechanism up here. This adjustment here allows you to take up for the axial growth of that exhaust valve stem as this engine warms up. So occasionally you'll spin this and make sure this is free. If you don't have this adjusted right, the exhaust valve won't sit against the seat and you'll have leakage. This particular engine is, valves are operated by the side shaft, which is run off of a gear on the crankshaft in the back. The governor also is driven off of this side shaft. You see here, you can see the cam lobe going around, and there's a single cam lobe that operates both valves. And these things are set 90 degrees apart. If you think about it, the shaft goes around once per cycle of the engine, and the intake and exhaust strokes are 90 degrees apart. It'll go intake, compression, power, exhaust, and come back around again. All right, this particular engine is a little bit different than a lot of gas engines in the fact that it has a cross slide similar to a steam engine. The cross slide guides the piston rod so that the piston moves parallel in the cylinder. A lot of gas engines have what's called a trunk piston, where the piston is long and allows helps guide the piston back and forth in the cylinder. And this piston rod is guided by a crosshead like a steam engine. A lot of gas engines that are the two-stroke cycle have a crosshead due to the fact that their piston, on the back side of the piston, that area is used to scavenge the front side of the cylinder for the two-stroke cycle. But this particular engine does not have an enclosed back side of the piston. Well, that's basically the story on this engine, so let's move on to the next engine in the museum.
When do they run these engines in here, Al?
A couple days in the spring for the spring show, and then this week every year, and a couple days in the fall for the fall show.
All right. Do you have any engines in here yourself in this particular building?
I have one with a partner.
I see.
Rick Foster and I own one engine in the rear.
All right.
An Alamo.
How large is that engine?
I think, if I remember correctly, 15 horse.
15 horsepower? All right. I wonder if we might be able to walk around here a little bit and take a look. I see there's one engine I'm really interested in over. There's a green engine over there with no crankshaft. It's not running at this time. Do you know anything about that engine at all?
I know a little bit. I'm not real sure of all the facts. It's Otto Langen. It was donated to us in a will from an estate, Mr. Willocks. Donated that to us.
He was down in Maryland, I believe.
Yeah,
Is that right?
It was in Maryland.
I wonder if we could take a walk over there maybe and just
Sure.
take a look at it.
Excuse me.
I'm standing here with John Wilcoxon. John, could you tell us a little about these two interesting engines right here?
The one you're looking at close here is an extremely early internal combustion engine. It's quite likely the oldest internal combustion engine in the world that runs. It was built in 1869 in Germany by Nicholas Otto, the inventor of the four-stroke cycle. But this engine is earlier than any of the four-stroke engines or the two-stroke engines. It fires without compression. It pulls a charge into the bottom of the column that you see there.
Into this column here, John?
That's right. There's a piston that works inside there, but it's not hooked up to a crankshaft. It's a free piston engine. And the piston is blown up freely when the charge fires underneath it, thrown way up in the air, thrown high enough it pulls considerable vacuum under it before it stops, and then it does its work on the downstroke. So it's called a free piston atmospheric engine.
Okay.
Because the atmosphere drives the piston down, and its own weight helps somewhat too. As it comes down, there's a freewheeling clutch up in this area, which engages and puts work into the rotating flywheel. And over here is a belt pulley, and it would be...
This is what would drive your
that's
machinery or something.
That's right.
Now, on this free piston, is there a ratchet in there or something that's, you know, it's your effort as the piston atmosphere pushes the piston back down, it engages with this shaft to give you the rotary
That's right.
rotation.
It's like a ratchet, but it's actually a freewheeling clutch that has a stepless operation, engages instantly when the rotation reverses. And it's one of the very early freewheeling clutches. That was one of the major obstacles in the development of the engine.
Now, would they be like rollers in there, or like egg-shaped cams? How would that actually?
There are 5 shoes with leather facings, which have ramps on their back sides and rollers working on those ramps, which are on mating ramps in the hub of the gear. So when it tries to rotate in the direction where it drives, these rollers run up the ramps and force the shoes in, and then the friction on the leather facings actually does the driving.
I'll be darned.
There's no springs in it at all.
That's really neat. And I see it's also governed with a flyball governor here.
The governor is not original on this one. The early Otto and Langens were furnished without a governor. The rate of firing is controlled by that little quarter-turn cock down there, which is in the exhaust line. And when you see it run, you'll understand how that works. The piston comes down freely as long as it's driving, but when the pressure in the cylinder gets up to atmospheric, it no longer drives the shaft, and it comes down very slowly after that because it's just pushing the exhaust out. And when it gets to the bottom, it tips a new cycle. So you can regulate the rate of firing by the rate at which it pushes the exhaust out. Very few engines covered anything like that.
Yeah, really, that is different.
And the governor was apparently put on in this country, probably by the Stevens Institute, because it's inch series in the threads and in the pins and so forth, while the rest of the engine's metric.
I see. Very interesting. Think you might be able to fire it up for us?
I think it'll run.
I'd love to hear it
ran
run.
last time we tried.
Very good. Let's see what you can do, John. I also see you're going to run this engine on hydrogen. Is that correct?
That's correct. We use hydrogen because it's as close as we can come to the city illuminating gas, which was the original fuel. This was made by distilling coal, and it was available in all of the large European cities as what they use in their gas lights. And the hydrogen is necessary to make the flame ignition work. This is before the time of electric ignition and before the time of hot tubes, which were a little earlier than the electric types. And it carries the flame into the cylinder from a burning pilot light through a slide valve.
I see.
And it's rather complicated, but it works.
Yeah, but think of this here. We're using hydrogen. If we can break water down, we can run this engine for nothing.
That's right. And what we run it on is the byproduct of making oxygen for welding. We can get hydrogen in cylinders.
There you go.
Cheap.
Right.
But all we make when we run it is water.
Okay.
Find my matches here. Maybe. Right here.
Now, what do we do with? Yeah. Okay. There's a pilot on it. Then I see.
Now there may be a little pop. I'm going to light the hydrogen. Now you can see there's a. Maybe if you bring your camera over here a little. You can see that there's a light in here that's external that burns all the time. Within the thickness of this valve, there's another pilot light that's fed by a separate line. And it's lit from the first one each cycle of the engine.
Okay.
Then isolated from the atmosphere and carried across, and eventually brought into communication with the port into the cylinder, so the flame fires in and lights the charge. But the high pressure then can't blow back.
Blow back because of this gate or valve there.
That's right. but the main explosion puts out the light that's in the valve, and it has to come back down and be relit each cycle from the external light.
Very interesting. Boy, this is different.
Must have taken a lot of development to make it work the first time.
Oh, boy, yeah.
But it usually starts pretty easy. I'm cutting back the main charge just a little bit there.
All right, that's your hydrogen line coming from the pressure regulator on the tank. Then.
That's right.
Okay. And here we go.
Turn the flywheel and initiate it. Cycle here.
And look at that. That is just amazing. And that's controlling the RPM by the exhaust.
Uh-huh. You can see the operation up in here. When the piston gets all the way to the bottom, it trips these eccentrics, which make a revolution. And one of them lifts the piston for its first 4 inches of travel, and that's what draws the new charge in. Then it's fired at atmospheric pressure, blows the piston way up, and then it does its work on the fast part of the downstroke.
This thing is really different, isn't it? Unbelievable.
This was the most practical engine on the market from its introduction in 1867 up until the time Otto developed the 4-stroke cycle in 1878. And the reason it was economical was because of the rapid expansion. Even though it fired without compression, there was very little time for heat to conduct into the water jacket because of the extreme rapidity of the piston action. It was on the order of 3 times more economical than the competing engines of the day, which had the piston connected up through a crankshaft and also fired without compression. And gas was very expensive then. It was a major item for them.
That is just unbelievable. What would be like the horsepower, let's say, of this? How is this rated?
We think it's a half horse.
1/2 horse. This is a lot of engine for a half horse, isn't it?
Right. It has no nameplate, no serial number, no marking of any kind on it.
And what was the, it's got a humongous stroke. What was the bore of this?
It's about a 5 3/4 inch bore. It's all metric.
Bore too, then.
And the stroke is probably intended to be a meter. It's about 40 inches.
40-inch stroke.
Uh-huh. We're not going as high as it possibly could, the way it's firing now.
Is there actually a stop in there? In other words, if you charge this harder, you could drive that piston higher, further up, which would give you a longer...
There are some rubber bumpers in there that it hits if it goes all the way, but you hope to run it in such a way
you
that
don't
you
want
don't
to do
hit
that,
those.
sure. That is just unbelievable. The flyball governor here is non-functional at this time. That's not being used?
We're not using it because it doesn't work. As I mentioned, it's not original and was probably put on here in this country. And the spool valve that they supplied with it was much too large, and just the leakage through that big valve defeats its purpose. It won't control the engine.
I see.
But Otto himself used a governor very similar to this, somewhat after this engine was built.
Uh-huh.
And then in 1872, the whole thing was redesigned and did away with the exhaust throttling and went to a mechanical governor and to a much simpler engine. Willick loaned it to us for a couple of years, about 12 years ago. And I spent several weeks on it, and Amos Stauffer, who was president of the show at that time, did the cosmetic work. He was the Deutz Diesel dealer in Holland.
Right.
And put his people to work on the painting and cleaning up. It was in bad shape. It had been through a fire and sat outside. It was rusty. Everything was stuck. And we made several parts, but everything major you see is original.
John, maybe you can tell us a little about this engine here.
What we have here is Dr. Otto's later design where the 4-stroke cycle was introduced. This engine has a crankshaft with the piston coupled to it, and it makes 2 revolutions to go through its cycle. And it was the first engine which used that principle of an intake stroke, and then a compression stroke, and then a power stroke, and an exhaust stroke.
Okay.
What Otto realized was that he could get lots more power out of his engine and much greater efficiency if he compressed the charge before he fired it. He was the first one who really concluded that and made a practical engine out of it. But he was still working with flame ignition like we saw on the other.
Okay.
And this engine has a slide valve, which is down here on this side.
Instead of the slide valve moving up and down on this one, it's moved sideways, right?
The slide controls the intake and ignition functions, and it has a poppet valve, which is right here. The poppet valve is the exhaust. Now, the original 4-stroke engines were introduced in 1878, and they were horizontal. This upright inverted model dates from the mid-1880s. But in principle, it's exactly the same.
There are some similarities to this as to the engine we just saw. You know, being the piston, being an upright engine like that. The only thing is that they've sort of taken the top off of this one and tied it to a crankshaft, as where the other one had the free piston in it.
Exactly. The vertical configuration was mostly for space requirements. So many of these were put in the small family shops where before the machinery was either hand cranked or foot treadled, and they didn't have machinery or room in the building to put in a big horizontal engine, but sometimes they'd have a little empty corner where they could fit one of these inverteds in.
Yeah.
And that's what they were introduced for. They were built with the slide valve up till about 1890. Very few flame ignition engines built after that. And there are only perhaps 4 slide valve flame ignition engines running in the country, even of the 4-cycle type.
Is
so
that
what
right?
you're seeing here is quite
And you have
unusual.
2 of them right here.
We have 2 right here. We have 2 more up in our Cool Spring show in northeastern Pennsylvania.
Very good.
But this engine was brought to the United States by Henry Ford. It was part of the collection he put together about 1930 for the Ford Museum and was on their floor for a good many years. It now belongs to a local collector here, Christopher Eby. And he's loaned it to us just for the show.
What do you think, John? Think you could fire this one for us?
It doesn't always start just as easy as that other one, but we'll start it up.
We could try, huh? Okay, very good.
Again, this is going to make a pop. This is going to make a pop.
Okay. John's going to light this the same as he did the other one. That sounds pretty good.
Regulate it there to give just a little bit of fuel for starting.
Okay. No complaints on the way that one started, John. She went right off.
Notice the pendulum governor here. Instead of fly balls, it has this little pendulum blade.
Yeah. Isn't that interesting? When that lines up, it opens the valve, right? That is neat.
Maybe you can hear the little pop. That's the
Yep, we hear that.
that's the secondary flame and the slide valve igniting each time it comes back and communicates with the primary pilot light.
And this engine is of the 2-cycle design, or is this? It must be.
This you'd call a 4-cycle.
This would be a 4-cycle. It's 4-cycle slide valve, though.
Right. As soon as the later ignition systems were introduced, which were either hot tube or electric, they did away with the slide valve and used poppet valves for the intake functions.
Okay.
The intake in this engine is controlled by the slide, and the gas and the air meet right in the middle of it. And the ignition, of course, is also controlled by it.
Now this, compared with the other engine, or this engine does create pressure in the cylinder.
Right.
No, it just has a compression cycle where the other one really doesn't have a
right.
true compression cycle. Is that correct?
It has a camshaft over there which runs half crankshaft speed, just
Right.
like modern engines.
Uh-huh.
It's not a super high compression engine by modern standard. It's
For sure.
like 2.5 or 3 to 1. You notice
yeah.
I didn't have to work real hard
Not
to
real
turn
hard.
it over.
Exactly.
But it has all the basic principles.
What would be the horsepower roughly of this engine?
It's about 2.
About 2 horsepower.
Again, it doesn't say on the plate.
Guessing you'd figure about 2.
It took them a while to decide on a standard. You know, they talked man power, and they talked nominal horsepower, which
Right.
is like the steam engine horsepower, and it didn't relate very much to our modern horsepowers.
That's a beautiful job. 2 very rare engines.
Most of these early engines run pretty nice.
Boy, they
You
sure
get the
seem
fix
to.
them.
They sure seem to. All right, John. Well, we certainly thank you for your time and explaining these engines. We really appreciate it.
You might enjoy the cylinder oilers here.
All right. Oh, wow, look at that.
This little wire comes around and dips in the oil, and then it goes across those trays and wipes off oil, which goes down. One feeds the cylinder, and the other feeds the slide valve.
That's really neat. Okay, John, well, we really thank you.
Oh, you're welcome.
Thanks a lot.
This is Roger Kriebel. He set this Otto and the pump up, and he'll tell you something about it.
Got a 6-horse Otto. It's made in Philadelphia by 1911. Well, come from the Bill Willock estate down in Maryland. We hooked it up to a 1911 Rumsey pump, 3-piston. And at 60 RPM, it'll pump 8,800 gallon of water an hour.
Roger, what are you using it for now?
We're using it to pump the cooling water for cooling the rest of the engines.
When it was pumping its capacity, how big an engine would have to be on the pump?
Originally, it was hooked up to a 15-horse gasoline engine. Runs a hit-and-miss principle. Follow the roller here. You can see the cam lift it. When it lifts the roller, it injects fuel into the cylinder and it fires. When it misses the cam, it just sucks air through it, and speed slowly drops until it picks up again. The governor here controls it. The fuel pump is over here. Pipe come across, goes up into the fuel valve, and goes into the cylinder. Okay. This engine's 6 horsepower, runs at 340 RPM, although we have it slowed down. Otto was one of the earliest internal combustion builders in the world. Comes from Deutz in Germany, who set it up in Philadelphia in 1877.
I think they all went to eat.
They went up to about 1930, 32 when they closed. The pump comes from a pump house on an estate up in Massachusetts. Nate got the engine and pump and kind of thought a triplex would be a nice pumping system, so he brought it down and we rebuilt it, and it turns out real nice. There's 3 cylinders, the crosshead here, and the plunger's in the bottom, and the valves are in the valve chest on the side here, and moves just about 2.5 gallons every revolution, which is rated at 60 RPM of the cranks, and put out about 8,800 gallon of water an hour. cylinders are 5.5 inches in diameter and an 8-inch stroke.
Roger, how about going over and showing us your 8-horse reed?
Okay. Okay, got an 8-horse reed here, serial number 270, which was built right around 1895. It's a very early reed, built by Joseph Reed Company in Oil City, Pennsylvania, used mainly for pumping oil wells. It was built on what they call the Clerk cycle. It works somewhat like a 2-cycle engine. This cylinder takes the charge of gas and air in it, and then it transfers it into the power cylinder where it's fired, and then it's exhausted out through an exhaust port. The ignition system runs on a hot tube, which has a flame burning all the time, keeps a pipe hot in here, which is connected to the combustion chamber. And it's kept red. When the engine comes up on compression, some of the mixture comes up through the tube till it hits the red portion and it splashes back into the cylinder.
Lily Bridge. This is his 35-horse Klein, and he'll tell you about it.
This engine was originally on the National Transit Pipeline in Western Pennsylvania, and it went out of service sometime in the mid-60s, I guess, or maybe early 60s, and it was brought here at that time. It's been kind of one of the favorite engines here ever since. It was installed in the pipeline system probably around 1897. The engine is number 99. It's It's called a Model 1 Klein, and it's rated at 35 horsepower. The engine's pretty unique in that it has a disc crank, a crosshead, and a strapped-in rod, which is indicative of early designed engines. It's got a 12 by 24 cylinder, 12-inch bar and a 24-inch stroke. Got 72-inch wheels. I'm sorry, 82-inch wheels. And it runs pretty nice. It's in good shape. Said there's this bar here that slides back and forth, which is directly connected in a straight line to the piston, and the throw is on the end of the crosshead. That's so you can have a short piston in the cylinder. The disc crank is something you don't see on too many engines. Right here, the disc crank. As you can very well see, the flywheels are pretty high. The whole engine weighs somewhere between 8.5 and 9 tons. I just think it's probably one of the nicest big engines I've ever seen. It's a little unusual in that it has a pull rod here rather than push rod for the valve mechanism. It has a rotary igniter on it, which is actuated by an eccentric crank on the crank. It's the only one that I know of that still has the original hand pump on it that can be used for starting. The only other engine I can think of offhand that has one like that is the early Fairbanks-Morse end. For the most part, I think it's a pretty nice showpiece. We here at the museum have had a lot of fun through the years running it for the public, and ourselves, of course.
Questions about this engine? Sure.
I see it. This is an Otto diesel, is that correct?
That's correct. It's built by the Deutz company in Germany and was imported by the Otto Engine Works in Philadelphia. This particular engine was built in 1923 and it's 35 horsepower. It was in the Roslyn Monument Works down near Philadelphia. And it ran an air compressor for their chipping hammers and also ran a line shaft for other machinery.
I see it's a side shaft engine.
That's correct. Yeah, it's side shaft. And it's a true solid injection diesel, and it's a cold start machine. You don't have to preheat anything, right? So it is a true diesel in that respect, but it is solid injection.
Belongs to the club here?
It belongs to Stauffer Diesel Sons.
Stauffer?
Right. That's Stauffer there.
Uh-huh.
We finally got the injection pump working.
Uh-huh.
So it belongs to them, but it's been here at the museum for quite a while, as I understand it. The appears since 1967 on it.
Is that right? Okay, Mike.
Here before the building was over.
Really? Yeah. Very interesting. Thank you very much.
Hey, enjoy the
Appreciate
show.
it. Thank you. A tag that they made up for this engine, Otto diesel, forerunner of the Deutz diesels, built in Germany in 1923, bore approximately 11.5 inches, stroke, question mark, aspiration naturally aspired, 4-cycle, horsepower 35 at 250 RPMs. The starting system on this engine is compressed air. It operated until 1962 by the Roslyn Monument Works near Philadelphia, Pennsylvania. Operated an air compressor and machinery driving a line shaft. Owned by Stauffer Diesel in Ephrata, Pennsylvania. Standing here with Lloyd Grubb, one of the owners of this Fairbanks-Morse 3-cylinder engine. Lloyd, I wonder if you could tell us a little bit about this engine.
This engine come off a tugboat in 1905. Then it was put on a drawbridge down Perryville, Maryland. They used it on the drawbridge till 1967. It got such bad shape it took a crew of 4 or 5 men 24 hours to start it. And then they junked it. They took it apart in pieces. They hauled it up here, laid up here for about 2 years. And one day they asked for volunteers to assemble it. I said I'd work at it. 3 or 4 other guys volunteered to help me. They lost interest in it. That made me happy. I stayed with it till I got it running. And I'm proud of it.
It sure sounds real good, Lloyd.
Well, I did a little work on it last spring. It took up the bearing noise, some of it. And it's running about as good as can be expected for an old engine.
And I see you have the side covers off the engine so we can look right in there to the crankshaft. That's pretty neat. I see your camshaft is on the far side of the engine, but you've got these rods going across. They're like cam followers, right, with rollers on them.
Yeah, well, you can reverse this engine. If you let it come to a stall and shift those cams,
The engine will run in either direction?
and if you hit it right, it'll go the other direction.
I'll be darned. That's interesting. Is that how, when the thing was on the drawbridge, they reversed it to close the bridge? They would just reverse the engine and run it the opposite way, or on the boat?
I think they had mechanism on the end of the crankshaft.
A transmission or
Yeah,
reverse gear or something.
reverse it. But on the tugboat, you'd reverse the engine.
Reverse the engine to back the tugboat up.
That's right.
Very interesting.
That's right.
I see from your information here, this was built in around 1900.
Yeah, well, you got to consider that in 1905, they took it off of the tugboat. Now, how long it was on the tugboat, I don't know. It could have been on there for 15, 20 years.
I suppose it could have, sure.
And while it was on the tugboat, it was running constantly. Constantly. Because you didn't, they would tow barges and so forth, moving freight.
Running 24 hours a day, probably, right? They'd change captains, but they'd never stop the tug.
The engine, that's right, the tug would run.
I see this has also got a flyweight governor up here on the back by the rear flywheel.
Yeah, this is throttle lever. Now, I got it anchored that nobody can tinker with that, because I don't want to run any faster than it is. It's an old engine, and I want it to run as long as I'm living.
There you go. I think at the speed it will, too, for
It
sure,
will,
huh?
it will. With proper care, it will.
Yeah, very good.
Proper care, it will.
I see that this engine's around 150 horsepower.
Yeah, that's right, yeah.
At about 150 RPM.
Yeah, it's running about 125 now, 125 RPM.
All right, Lloyd, look, we really thank you for the interview here.
Well, glad to talk to you.
Thank you. Very interesting.
Any questions?
Well, not really. I think you more or less covered the whole thing.
Ain't much more to say about it.
A real nice engine. No, you covered it from A to Z, I'd say. Very good, Lloyd. Thank you very much.
Thank you.
This engine is a 16 horsepower Jones, around 1900, made in Toledo, Ohio, owned by Kevin Huber of Titusville, New Jersey. This engine is a 20 horsepower Alamo, manufactured in Hillsdale, Michigan. Excuse me, owned by Cliff Foster and Al Stickney. This engine is a 20 horsepower Oil City Boiler Works, manufactured in Oil City, Pennsylvania, owned by Christopher S. Eby of Paradise, Pennsylvania. Here we have a 25 horsepower Whitty, manufactured in Kansas City, Missouri, owned by Ed Johnson of Baptisttown, New Jersey. This engine here is a 17 horsepower Otto side shaft, manufactured in 1893. Owned by Schlichter, Schwinn and Company, Philadelphia, Pennsylvania. The owner is Roger Krybel of Harleysville, Pennsylvania. Roger, can we talk to you about this engine a little? Do you have any history on this engine?
Oh, I took it out of a grist mill down in Glen Rock in York County about 1973. And it was supposedly put in about 95, as the old guy recalled, but designs from literature and everything show it to be about 93. And it's a 17 horsepower. I believe it's about the oldest Otto with electric ignition. It runs spur and bevel gears instead of regular crossed helical gears for the side shaft. Built by Schleicher Schumann Company in Philadelphia, which about that period of time was changing their name to the Otto Gas Engine Works.
I see. This engine's in real nice shape.
Yeah, it's still got the original paint on it yet.
That's amazing, isn't it?
Cleaned up the bright work on it. It's got a mechanical oiler on the cylinder there. Lift the lid off. Yeah.
Oh, look at that.
There's a little dipper goes down in the oil and then wipes it across the pins, and then the oil runs down
the pins, and then one lubricates the piston, and what's the other
No,
one?
that's all it does. It's
Two
of
drippers
them.
both lubricate the
Yeah, they
piston.
both lubricate the piston.
That's wild.
We'll get done cleaning it up, we'll get it running.
Real nice job.
Thank you.
Thanks a lot, Roger. We're here this morning with Nate Lillybridge, who is the proud owner of this beautiful Miller engine, and he's going to tell us something about it. What can you tell us about this engine, Nate?
Well, first of all, I got to agree with what you said. Beautiful engine. It's probably one of the nicest machine-built engines in America, both design-wise and machine finishes, and in the engineering part of the engine is unique. It stands by itself as far as I'm concerned. It's got all these nicely machined surfaces and all the nicely bent brass pipe and oil system on it. Big Jans governor. The flywheel is machined both on the sides and the belt surface. And not only that, it's made out of what they call real cast iron in those days, some real weight. The engine itself probably weighs in the vicinity of 18 tons.
Is that right? Wow. I see that this engine has crossheads on it. Now, a lot of your gas engines don't have them, isn't that true?
Well, that's correct. Generally, the larger engines that had the larger diameter bores had crossheads in them so that the pistons would run straight or parallel with the bore of the cylinder. And that they took the radial motion from the linear motion off of the crosshead. And that means that the piston length could be smaller in the cylinder, and you wouldn't have the added length to support a long piston. It really reduced weight, and it also, conserved floor space as well, because otherwise the engine proportionally would have to be longer.
And probably cut down on some internal wear besides, being the piston was a little shorter.
I'm sure of that. I'm sure of that. One of the things that's unique about this engine is on a big foundation block. It doesn't look much from the surface here, but subsurface, the foundation block goes from probably about where I'm standing here.
Way out here?
Yeah, somewhere like out in here. Here across on the other side, and it extends out to the front edge of those pipes. And there's 17 yards of concrete in here, and it's one block. The two foundation blocks that come up with the two cylinder halves are tied in intricately under the ground. So
is that right?
It's one foundation block.
17 cubic yards.
That's right, of
wow.
concrete.
That's amazing.
And when the engine runs, there's no vibration. It runs just like a Hamilton watch, nice and smooth, and you can't see any movement at all of the engine.
What is the bore and stroke of this, two-cylinder engine here?
The bore it's a 15-inch bore with a 23-inch stroke.
Wow. And the horsepower developed?
125 horsepower.
125 at about,
I would say somewhere about 240 probably, something like that. Maybe a little bit faster.
Now this engine was originally used for, what was the application?
They run a flour mill in Bucyrus, Ohio. I never did see the building, but it was described as a 3-story building that occupied quite a bit of like a city block.
Is that right?
And of course, when it was built, the mill was built, it was kind of on the edge of town. As the town grew and become more populated around the mill within the city, and they decided to discontinue the mill there, and they moved it on the outskirts of town and put all modern equipment in it, and left the old building and the engine there for whatever would happen to it, I guess.
And that must have been some project to disassemble this and then, of course, reassemble it here.
The project itself wasn't done by myself. It was done by a good friend of mine, John Wilcox, and he disassembled the engine in the basement of the mill and took it all up the stairs. The people would go up and down the stairs on. He had to shore the stairs up and the floor up and take it apart piece by piece and move it up the stairs so he wouldn't destruct the mill. At that time, they didn't know what they were going to do with the building, and they didn't want to ruin the building, so he had to take it apart and take it out piece by piece.
Basically, almost had to be carried out by hand then.
Yes, that, and little come-alongs and cradles that he made and things like that.
Boy, oh boy. Would you be able to maybe get this thing started for us? We'd sure love to see it run.
It would be a pleasure.
Very good.
Okay.
Let's see what we can do with it.
All right. We can go over here and...
All right.
First thing we're going to do is roll the flywheel up so that the offside cylinder is on top dead center or a few degrees beyond top dead center on the power stroke, because at that point we'll shoot that cylinder with air. And when we shoot that cylinder there, we can go through what happens over there at that time. But that cylinder goes from a 4-cycle gas engine cylinder to a 2-cycle air engine.
Air engine. So in other words, you're actually going to start this engine. It's too heavy to turn over by hand. You will start this engine with compressed air.
That's correct.
And just to turn this engine, they're using a big piece of 4x4 there to pry the engine around into position.
When Miller built the engine, they supplied a winch for it. The rope goes on the other side of the flywheel. We'll look at it when we go over there with a rope winch, and then you just take that winch, and there's 2 holes in that machine pulley, so you can put like a keeper in and hold the rope, and it would go around that slot, and you have a winch over there, and you could crank the winch and turn the engine on location for starting.
What is this engine fueled with?
We're running it on propane right now.
On propane?
I think originally it probably ran on producer gas or city gas.
Okay.
Okay, we got the plugs back on location. Now I've got to go over and turn the air valve on.
All right.
Okay, are we ready to start it?
Yeah, look, I'm
Or
ready
maybe
to
I
see
should
it.
say attempt it.
Let's see what happens. I'm gonna turn the fuel valve on here.
Right. We set this to right there at a 1/4. And we make sure nobody's behind it.
Okay, here we go.
There it is.
Well, looks like it's running. Nathan's advancing the timing on the engine now.
And it went off like a watch.
That's the way it's supposed to do it, isn't it? Beautiful.
Yeah. Now I'm going to go shut the air off so that this don't happen to get turned on while it's running, because it would just disintegrate.
Is that right? The engine now is running at about 250 RPMs.
Now we can go around and adjust these.
Just hold your hand on them and
Just bring this up, and
yeah.
eventually it'll bottom out.
I just want to feel just a slight
Right
grab.
now it's bottomed out, so
Yeah.
you just back it off and you lock it in position.
Turns the roller till he gets free play in it. Back till he gets that slight bit of free play and locks it in place.
That's it.
Boy, that runs beautiful.
Yeah, it seems to be as well as I would expect it to run. There may be a few little things that I can adjust later on, but they're not obvious to me right now. I think if you go over between the 2 exhaust pipes and listen to it, you'll be able to hear the rhythmic opening, closing of the exhaust.
Valve, yeah.
And it's really nice.
Very nice.
I think you have it at right now.
Oh, it's probably around 160, I would think.
Underloaded would run wide.
We've got a shot here of the rear of the cylinder. From there we go down to the crosshead, which is here. This particular engine, the piston has a straight linear motion. This crosshead here changes that to the reciprocating motion. These are the oilers, both for the crosshead. This one here is touched by the connecting rod oiler there. That lubricates this end of the connecting rod. Then as we pan down towards the crankshaft, we can see down there the main bearing blocks, the flywheel, the crank throw. This is an interesting oiler here on the crank throw. The oil drips from up here in the oiler down through this pipe and into this little ball looking thing. The oil drips into that ball and then is picked up inside the ball, and the centrifugal force throws the oil out to the connecting rod on the end of the crankshaft there. Beautiful plumbing on this engine, all nice bent brass tubing, beautiful oilers on it. This is really a fine looking engine. The main bearing blocks are very similar to an old steam engine style main bearing blocks. This big Miller engine is also a side shaft engine. With the valving up front there, we'll get a chance to get up there and take a look at some of that interesting valving. The governor and the magneto, both including all the valving, run off that side shaft, which is on the other side of the engine there. This is all your valve mechanism here. This valve chamber here is where all your timing is done. These push rods here go up to the exhaust valves. These adjustments up on the top of the exhaust valve, as this engine warms up, the valves have a tendency to grow in length. These adjustments up here compensate for that extension and length of the valves due to the heating of the valves. Your intake valves are inside of this chamber here. These are your exhaust pipes going down in the ground out to the outside the building. This is your mixer down here. This is the fuel, which is propane gas, and this is your air, the other valve below it. And then this item right here would be your mixer. This is a two-cylinder engine, so you have basically one cylinder here on the left and the other cylinder on the right. Basically the same. Maybe we can get around on the other side there and get a shot of the magneto. We've got on this side of the engine, this would be the left side of the engine now. We want to show you some detail here as far as the magneto goes, which is this item right here, which runs on the side shaft, which runs through the magneto. Back here to these gears in the back, which run off the crankshaft. Also running off of this side shaft is the flywheel, which is a flyball governor, which is this item right here, spinning around. And this is what controls the RPM of the engine. Is that flyball governor right there. Also, if you move forward from the magneto a little bit, you'll see this is your water cooling. And you can see where the water's coming, the water drains, draining the water out of the cylinders after it's cooled the cylinders. Keep in mind, this side now is just basically the same as the other side of the engine. Two-cylinder with a single flywheel. one of Nate's real nice engines. Nate, what can you tell us about this Klein engine?
Well, obviously it's certainly a nice big engine. It weighs in the vicinity of 15 ton. It's got two 13 by 24 cylinders, and it was the workhorse of the oil fields in the turn of the century. It basically was used in the collection stations where the oil was pumped out of the woods to the holding stations, and then it was engines like this that pumped it from the collection stations to the refineries. This particular engine was used in southern Ohio, and it pumped the oil from there down to the refineries.
What kind of distance would you be talking about, probably, where something like this would pump
an engine like this would pump oil anywhere from 50 to 100 miles.
Is that right?
Yeah.
Wow.
There was two engines in this particular station that this was in, and when they took the 290 horse Kleins out of service, they put a 200 horse Cummins in it, and after running it for a half hour, they concluded that the Cummins didn't have nearly enough horsepower to replace these two engines, so they put another 200 horsepower engine halfway up the mountain in the pipeline to supplement the initial installation.
And of course, those Cummins are probably running like 2100, where these things are running a little over 100.
Well, generally they ran these between 160 and 180 RPM.
Now, what does three-ball mean as far as a three-ball Klein?
Well, I'm sure that they're making reference to the governor head up there with the three balls.
Three balls on the governor, on the fly ball governor. Very nice. This is a real nice unit. Now, you've got this engine running now on propane?
Yeah, this engine runs on propane. Originally, it ran off the natural gas off the wellhead. So, we run them on propane. It's a good fuel, and it burns clean, and it does us well.
Now, the natural gas that they ran these engines on right out of the wellheads, they just filtered the gas and they used it that way, or did it have to be processed? Or
no, they didn't process it. They took it right off the wellhead, right off the casing, and pumped it directly to the engine. I can't recall ever seeing a filter on it. I can recall taking engines apart and seeing a lot of dirt and fine silt in the engines where the gas came right off the head, so I don't think there was too much filters going on.
They just ran the gas right out of the wellhead right to the engine.
Just like they got it. It was cheaper that way.
Now, how do you start this engine?
Well, you get in the flywheels and you tramp it. We haven't hooked the air up on this one like we have some of the others.
I see.
And it's generally because by starting it by hand this way, the people that watch it start that way really get a big kick out of seeing people climbing in the flywheels.
Climbing up the flywheel to spin it over.
Because one of the things that you have to do is make some adjustments, like there's some spark retardant you have to do, and you have to change the lobes on the cam so that you get some compression release when you're coming up on compression, because you never could turn it over by hand.
Turn it over on full compression.
No. So we got water running now. We got gas up to the engine. If you want to go through the logistics of starting it, we can walk around in the front and
I'd sure like to do that. Yeah.
First thing we generally do before we try to start the engine is test and verify that we have electric ignition. That way you don't end up tramping it for nothing and getting tired.
Yeah, because that's a lot of work to keep that engine spinning.
All right, now we're ready to start it. You guys ready?
All right. Looks like we got some help here.
We got some help here, so we shouldn't have too much trouble. Okay, let's go.
There we go. They're going to rock it backwards. There we go. You hear a little pop out of it there. I think this is a good reason to put compressed air start on these engines. This will wear you down for sure.
I don't know what that noise is.
Might have kicked a little right then, huh?
men. Good job.
Bit to get her going, but she runs good once you got her fired up. Yeah, it's a matter of getting the gas cock set and adjusted right. It makes a little bit difference between the summer temperature and the fall temperature where you set it. You just have to find it. What else would you like to know about that big beast?
I see the information. It's got, what is it, 412,000 hours on it?
Yeah, I'm sure that it has all of that. You know, that's just calculated based on talking to the engineers that's been around the station.
Been in service a long time, I guess.
It sure has. It's in relatively good condition, too, for the length of time that it's been run and seen service. This is the only one that's really complete that I know of in running. A friend of mine, John Wilcox, who we've mentioned earlier in the program, also has one at home, and it's, you know, it's in rare disassembly where he took it out of the building, but he also has one of the old ones.
Are there any of these engines still in use in Western Pennsylvania that you know of? Or?
You mean twins like this, or one-cylinder gas engines?
One-cylinder gas engines, or?
There are a few that's being used yet, and they're basically owned by private pumpers. I don't know of any that's owned and operated by, you know, a major company. But they may very well be, but if there are, there's very few.
But any of the pumping they're doing today is turned over to like Detroit's or Cummings or something like that, right? With it?
Probably electric more than any of them.
Okay, yeah.
You know, if the electric is accessible, they'd use electric. But I guess in some of the remote areas, they may have a gas engine of some type in there.
The pump was flat belt driven off the pulley over there, yeah. Big pulley.
Some of these engines pump as high as 1,000 psi in the winter, and they had
right. Wow.
And I have never seen it, but I've been told by people that, you know, frequented the oil fields looking at engines through the years, where the gasket between the flanges of the pump and the pipeline, where the gasket would let go in the wintertime, and there was so much pressure it would blow the aluminum sheeting off the roof. That's how much pressure there was in that system.
Wow.
And then they used to take, because of the oil was so heavy and so thick, to reduce the viscosity of it, they had bypass piping around the pump back to the suction line, and they'd take half of the oil and push it right back in the suction line to heat it up and reduce the...
No, it's just the friction of it circling around would warm it up a little bit.
Well, that and going through the pump, you know, when 1,000 psi come down on you.
There's a lot of temperature created there. Yeah.
It would change your resistance factor, I think.
Yeah, for sure. That's interesting. Well, Nathan, we want to thank you very much for talking about this engine with us and starting it up for us.
You're welcome.
Really enjoyed it.
My pleasure.
Thanks so much.
Visit us again.
Hope to do that. We will for sure.
this one, the base was poured in '73.
Right.
And it's been worked on a little off and on up until 2 years ago when Nate got it. Then everybody went gung-ho on it.
Right.
Al, we sure do want to thank you for your time you spent with us and all the information. Also, the other members of the club that spent time with us. You sure do have a beautiful display here. Thank you so much for your time.
Thanks for coming.
Thank you.